tapply is useful because it splits up a vector into little pieces, and it applies a summary statistic or function to those little pieces, and then after it applies that function, it kind of brings the pieces back together again. So split is not a loop function, but it's a very handy function that can be used in conjunction with functions like lapply or sapply. And so I just wanted to mention it here. So split takes a vector, so it's kind of like tapply, but it's like tapply but without applying the summary statistic. So what it does is it takes a vector or an object x, and then it takes a factor variable f, which again identifies levels of a group, and then it splits the object x into the number of groups that are identified in factor f. So for example, if f has 3 levels identifying 3 groups, then the split function will split x into 3 groups. And then once you've got those groups split apart, you can use lapply or sapply to apply a function to those individual groups. So here, this is a simple example similar to what I had before. With the tapply example, I've simulated a normal, 10 normal random variables with mean 0, 10 uniforms, and 10 normals with mean 1. And I'm creating my factor variable here. And now I'm just going to split the vector into 3 parts because the factor variable has 3 levels. So now you can see when I split the x vector, I get a list back, and the first element is 10 normals, the second element is 10 uniforms, and the third element, which gets a little cut off here, is 10 normals again. So that's what the split function does. So now so split always returns a list back, and so if you want to do something with this list, you can use lapply or sapply. So here, for example, it's common to use the lapply function in conjunction with the split function. So the idea is that you split something and then lapply a function over it. Now in this case, this use of lapply and split is not necessary because you can use the tapply function, which will do the exact same thing. It's not any more efficient or any worse to do it this way, but the tapply function is a little bit more compact. But the nice thing about using the split function is that it can be used to split much more complicated types of objects. So for example, here I've got a data frame. I'm loading the datasets package, and I'm looking at the air quality data frame from the datasets package. So you can see this is the first 6 rows of the this data frame. I think there's about 100 some rows in total in this data frame. And you see there are measurements on ozone, solar radiation, wind, and temperature, and then the month, and then the day within that month. And so one thing I might want to do is calculate, for example, the mean of ozone, solar radiation, wind, and temperature within each month. So for in each month, there's 30 some observations, and I want to calculate the mean within each month, right? So how do I do this? Well, what I'd like to do is I'd like to split the data frame into monthly pieces. And then once I've split the data frame into separate months, I can just calculate the means, the column means, using either apply or column means on those other variables. So that's what I've done here. What I've done is I've split the air quality data frame, and the factor I'm going to use to split is the month variable. So the month variable, technically speaking, in the data frame is not a factor variable, but it can be converted into a factor variable because it only takes the values 5, 6, 7, 8, and 9. Because the measurements are only taken in the kind of warmer months of the year. So here I've split the air quality variable according to the month variable, and then I'm going to apply an anonymous function. And the anonymous function here, what it does is it takes the column means of just the ozone, solar radiation, and wind. So I'm not going to take the mean of temperature here. So I'm just going to take the column means of those 3 variables for each month, each kind of monthly data frame. So here you can see the results. You can't see them all, but you can see most of them. And you can see lapply is returning a list back, where each element of the list is a vector of length 3, which is the mean for ozone, the mean for solar radiation, and the mean for wind within that month. And so you can see that for most of the months, the ozone value is NA, and that's because when I take the mean of that column, there are missing values in that column, and I can't take the mean if there are missing values. So the result when I take the mean is that I just get a missing value back. So one thing I can do is so before I fix the missing value problem, I can also call sapply here. And the idea is that sapply, instead of returning me a list, it will simplify the result because each element of the returned list is a vector of length 3. They're all the same length. So what it'll do is it'll put all these numbers into a matrix where there are 3 rows and in this case 5 columns. So here you can see the monthly means for each of the 3 variables in a much more compact format. It's in a matrix instead of a list. Of course, I've still got NAs for a lot of them because of the missing values in the original data. So one thing I can do is I'm just going to pass the na.rm argument to call means. That will remove the missing values from each column before calculating the mean. And that now, when I call sapply on the split list, I can get the means of the observed values for each of the 3 variables for each of the 5 months. So split is a very handy function for splitting arbitrary objects according to the levels of a factor, and then applying any type of function to those split elements of that list. And so here I've split a data frame. You can split other lists, or other kinds of things too. So the last thing I want to talk about is splitting on more than one level. So in the past couple of examples, I've only had a single factor variable, and I've split whatever the object is, a vector or a data frame, according to the levels of that single factor. But you might have more than one factor. For example, you might have a variable that's it's gender, so it has male and female, and you might have another variable that has, for example, that's race. And so you might want to look at the combination of the levels within those factors. And so here I've got f1, which is a factor with 2 levels, and so I've simulated a normal random variable 10 times with 10 observations. I've got a factor with 2 levels, and each repeated 5 times, and then I've got another factor with 5 levels, each repeated 2 times. So these are my kind of two grouping variables here, and I want to look at the kind of combination of the two. So I can use the interaction function to combine all the levels of the first one with all the levels of the second one. And so because there's 2 levels in the first factor and there's 5 levels in the second factor, there's the total combination of 10 different levels that you can have when you combine the 2 together. So when I call the interaction function, I get another factor that kind of concatenates the levels of one with the other, and you can see that it prints out that there's a total of 10 levels. Okay. So now I can split my numeric vector x according to the 2 different levels. So now when I use this, when I use the split function, I don't have to use the interaction function. I can just pass it a list with the 2 factors, and it will automatically call the interaction function for me and create that 10-level interaction factor. So I can just pass it a list of these 2 factors, and you can see that it returns me a list with the levels of the 10 different kind of interaction factor levels, and then the elements of the numeric vector that are within those 10 levels. Now, of course, although there are 10 levels between the 2 different factors, we don't exactly observe every single combination, and so there are some empty levels here. And you can see that some of these levels have nothing in them; they have 0 elements, whereas other levels have a number in it. And so one thing you can do. Well, first, I could take this list and then lapply or sapply a function over it if I wanted to. But sometimes it's a little bit handy to not have to keep these empty levels. So the split function has an argument called drop, and if you specify drop equals true, it will drop the empty levels that are created by the splitting. And this can be very handy when you're combining multiple different factors. If you're only using a single factor, then that argument doesn't really do anything because you just use all the levels. But usually, if you have multiple factors, then typically you're going to have empty levels just because you don't observe every single combination of the 2 factors. So drop equals true will drop those empty levels, and then you'll be returned a list with only the levels that have observations in them.